Okay, number 82. Figure above, this is a graph of a derivative, of which describes the maximums and minimums and all that. So here, the derivative is going from positive to negative. So this right here would be a maximum. It goes from negative derivative to 0, but then negative again. So that would be like something that looked maybe like this on the original function. So this is neither. And then here it goes from decreasing to increasing. So this would be a minimum. So I've got one maximum and one minimum. So that's all these are wrong. And then points of inflection. Points of inflection are just maximums and minimums of the first derivative. So I've got 1, 2, 3. Right, they're places where the slope of the derivative changes sign. So that's maximums and minimums of f prime. And they could be sharp corners. That would be okay. All right, that was 82, 83. Table above gives values of f prime, and if f of 1 equals 4, what's the approximation to f of 2 obtained by using Euler's method with step size of 0.5? Okay, so I'm going to go from my x values, I'm going to go 1, 1.5, and 2. My y value I'm starting at 4. The slope, dy dx, here it's 0.2. And then here I need to do dy dx times delta x, and that gives me my approximate change in y. And delta x, we're going up by 0.5. So I take this and multiply by 0.5. That's my delta y, so that brings me to 4.1. And then the dy dx, just going to get that from the table here, it's a half, or 0.5. To multiply that by 0.1, that's 0.05. No, it's not. Just kidding, that's 0.25, that's what I meant. And then add that over here, so that's 4.35. And you could use your calculator in there as much or as little as you want. All right. A sphere is expanding in such a way that the area of any circular cross-section through the sphere's center is increasing at a constant rate of this. Okay, so that's the cross-section through the center of the sphere, so that's like a circle with radius r. Right, so the area of that circle is pi r squared. So this is like dA dt. Oh yeah, this is related rates, by the way. So dA dt is equal to the derivative of this is 2 pi r dr dt. And dA dt, they're telling us that the area of that is increasing at this rate. So this is 2. And it's a constant rate. At the instant when the radius of the sphere is 4 centimeters, what's the rate of change of the sphere's volume? So let's see. Volume, I'm not even going to think about anything except for finding the related rate equation here. So I'm going to take the derivative of this, 4 pi r squared dr dt. So they want to know at the instant when the radius of the sphere is 4 centimeters, what's the rate of change of the sphere's volume? Okay, well, let's see if we can do that. So that would be 4 pi at the instant when the radius is 4. Now what about dr dt? Well, here, when the radius is 4, that'd be 2 times 4 is 8 pi dr dt. So dr dt is equal to 1 over 4 pi. I think that's probably the hard part of this problem. So it looks like it's 16. That you had to use this thing about that to be able to figure out an expression for drdt. Little tricky, but I mean, you have to believe that you can do these things. Just start with these equations and find your related rates. Go from there. '85. Components of the velocity of a particle moving in the xy plane are given by these parametrics. So this is the x velocity and the y velocity, where k is positive constant, and this line is parallel to the line tangent to the path of the particle, where t equals 2. So that means slope is 4. And so they want to know what's the value of k. Well, slope is equal to dy dx. So if I've got parametrics, that's y prime over x prime, or dy dt over dx dt. So let's see, y prime is k e to the kt over t plus 1. Okay, and this having a slope of 4 happens when t is 2. So that means that k e to the 2k is over 3 is equal to 4. So k e to the 2k is equal to 12. Now, there's not really any way to solve this except just by graphing it with your calculator. So I'm just going to get everything on one side here, get this old stuff out of here, and so let's see. So x times e to the 2x, and then I'm going to just do minus 12. You could graph 12 separately and then look for the intersection. Of course, 12 would be off of the regular screen. And I'm going to see if I can find the zeros of this. Oh, that's an old graph. I should not have done that. I should not. Oh, I got lucky. I'm not a big fan of pushing graph without checking what the window is first. So I probably would have gone back to the standard window. So let's just pretend I did that. So it crosses here. That looks like 1-ish. So if I just had to guess, well, I guess I'd guess one of those. But I don't have to guess, because I'm going to find where it crosses, what the 0 is, and it looks like it's definitely in between 0 and 2. So I'm not going to play the cursor game. I'm going to type in 0 and 2. 1.16. That's not one of my choices. Let's see. What did we do wrong? Oh, sorry, this is 1 over that, so this is that, which would make this not 12, but this would be 4/3 when I multiply that up there. I'm sorry about that. So let's fix that. That's 4/3, and we'll try that again. Alright, so that looks much more like in between 0 and 1 now. So second calculate 0, left bound. Looks like I'll just go between 0 and 2 to be safe. 0.495, and there's that. That's your choice, C. Alright, 86. Table above gives the distance as a function of time that a car has traveled at various times t, where t is in hours, during a 6-hour trip. The graph of the function s is increasing and concave up. Probably going to need to know that. Based on the information, which of the following could be the velocity of the car in miles per hour at time 3? Alright, so let's see if we can figure that out. I could figure out what the average velocities are in between these. So that went 25 miles in 1 hour. And here, this is v of t approximating. Here, that went 30 miles and then here looks like we went 37, and then 58, and I don't think I really care about what happens after that. But those gaps need to be getting bigger and bigger. That's the concave up, right? So if this is true, that means the somewhere between here, by the mean value theorem, somewhere between here and here, it actually has a velocity of 25, and likewise and likewise. So it is increasing between these. So somewhere between 1 and 2, what do we want at 3? So somewhere between 2 and 3, this actually has to have a velocity of 37. And somewhere between 3 and 4, it actually has to have a velocity of 58. The only possible things it could have are things that are between 37 and 58. So that's the only thing that's between there. It couldn't actually be 37, because then it would have to be flat from here to here, and that would violate the increasing. Right? It has to be in between those.
Mr. Jarvis, please dial extension 3503. Mr. Jarvis, please dial extension 3503.
And I'll make this the last one for this video. So if we have the terms of one series that are trapped in between 0 and the terms of another series, which of the following must be true? So what that means is all of the terms of the A series, A1, A2, A3, that the B series is trapped underneath. So, what has to be true? If the limit as n approaches infinity of this is 0, then Bn must converge. Well, what does this mean? If the limit as n approaches infinity, if the A terms are approaching 0, then that's the you're telling me that there's a chance for convergence, but it doesn't necessarily converge. And if this one's trapped underneath something that doesn't necessarily converge, then this does not necessarily converge either. So that's not it. Now if this one converges, if the A series converges, well then the B series trapped underneath it must also converge. And if it can't converge without the terms going to 0, so this looks awfully good. You could put a middle logical step in here. If the A series converges, then the B series converges also. And then that means that this must be true. So let's look at these other ones. If B diverges, then, well, if B diverges, then the only thing we could say for sure is that A must also diverge, and that doesn't necessarily mean this or the opposite of this either. It could be either way, because we could have a divergent series where the terms are getting close to 0. It's just there, you were telling me there's a chance, and then there wasn't a chance. It didn't work out. So that's no good. If the A series diverges, then B, well, I don't know anything about that. If the A series diverges, it just means the B's under there somewhere, but it could be, could be still converging. We don't know how these are bound together, or if they are at all, except for that the B's are underneath. So that's not true. If the B series converges, then A well, B's underneath, so if B converges, all I know is that A is up there somewhere, so that's no good. So the correct answer there is B.